Okay, my guys and gals, let's start today's session. I want to apologize for the previous video. At first, I told you that we're going to be working on the cross-entropy method today, and then I changed my mind and told you that I wanted to work on a hand ranker. But in fact, what we're going to be working on is a bucketing scheme. I found this paper by Jonathan Lin, and it's very much all programming and no math, much like I like it. I won't go over through all of this. It's a pretty basic paper, but it had something interesting for me here. What he did here is make various variations of a handcrafted player. Like this yellow line is a random player, very similar to the one that we have right now. He also made a few other players like aggressive, calling machine, tight aggressive. I'm not sure what the initial weights one is, but the rest is explanatory. He also talked about that he did a bucketing scheme to train a CFR agent. Post-flop bucketing algorithm. Oh yeah, and he also had a pre-flop bucketing algorithm. Okay, so what I really want to do is implement the cross-entropy method and try to train with it. As I mentioned in the previous video, back in 2021, I tried training a hand ranker with the supervised learning, and it couldn't reduce the error to zero. Even after hundreds of millions of hands, it was still making errors regularly. And let's not talk about what happened once I actually tried training it on the full no-limit hold'em game. I basically got trash behavior, much like we're getting now with the tabular CFR and the random weights. So, as an intermediate step, I want to get a player that's at least decent, even if it's not very good. And for that, instead of using a neural network, in order to generate the infoset ID or the world ID that we are using in our own CFR implementation, that's what we are calling it, we should be implementing this. Like the input hand and board was the board paired. Boards have more than 3 of the same suit. Check full house no draw, flush no draw, straight no draw, straight draw, straight no draw, made hand, check highest. Oh, I see. So this is basically just doing the hand ranking, much like we are doing. Like we are doing it hand ranker module. Excuse me, I just need to set the keyboard. No. Yeah, basically we are doing the hand ranking here. And this returns the score. And it returns the hand sorted from highest to lowest rank. Over here, he's doing a bunch of extra stuff, like he's checking for middle pairs, he's checking for highest and over pairs. He's also checking whether a flush draw exists or doesn't. I guess he is treating the flush draws and the straight draws the same here. Yeah, this is pretty interesting. And over here is the board double paired, max calculation of the same rank. Calculate max of the same suit of the max rank. Here he has the betting history. Of betting streets single blind raised, of betting streets big blind raised. Also, max number of existing cards in the window of 5 consecutive ranks. In the paper, he mentioned that he couldn't find a bucketing scheme on the internet, so he implemented this on his own. And I very much like this kind of attitude, and I wish that I had it myself instead of getting mired in uncertainty. So yeah, we should be implementing something like this and using it to generate the whole ID, and then trading the heads up no limit hold'em agent using that. I'm looking at this right now, and I cannot see the pot and the stack sizes anywhere here. He's throwing away the exact, the pot size and the pot sizes that have been raised in betting history, and just counting the number of times this has happened. Okay, so this element key boolean question has two possible outputs, true or false. Bucket output two element tuple. Okay, I cannot understand this. I mean, it's not pointing to anything here. So this is like a legend. So the boolean question has two possible outputs, true or false. This is this orange thing, orange brown maybe. This this gray, that's like that's like the superclass of these two, and this black thing is the bucket output two element tuple. I guess this is referring just to this, but this is actually a for tuple. Wait, and this is a tuple of raising history. So I guess it's just merging the small blind raised and big blind raised. And the small blind and the big blind are referring to player 1 and player 0 respectively. Player 0 is on the big blind and player 1 is on the small blind. Yeah, okay. Yeah, so I guess we're going to have to do some pattern matching. Bucketing. It's not possible to reach all unique info sets in a feasible amount of time. In fact, there are more info sets available in poker than atoms in the universe. Therefore, a concept called bucketing is required for large games such as poker. Bucketing is spooky. Bucketing is putting similar info sets and would have similar strategy in buckets. Yeah, so that's what I'm considering here. Oh yeah, I'm going to just leave a few comments just in case that Jonathan Lin ends up watching this. This stuff on multi-threading, well, I'm not really aware of which language he's using, but he's talking about how thread locks and threads are expensive. If he used something like a programming language with green threads, such as Go, or a concurrency library like Hopak. F# has a really good concurrency library called Hopak, which implements standard ML concurrent style. It's a concurrent ML style concurrent programming library for F#. It's what I used to create the language server for Spiral, and it made it much easier. What it does is has basically things like channels that you'd find in the Go language, or closure async, or even racket. It's kind of abandonware at this point, but it's still a very good library despite that. I think the author of it is now working on the multi-core implementation for OCaml. Yeah, that's one thing that I wanted to mention. And here he is talking about biased reward function. And what this is simply emulating a rake. If you think about it, over here he is basically multiplying the loss by 1.5 5, but it's that would essentially be the same thing as if he divided the reward by 1.5, and in the end you get the same thing as the rake. I guess he was trying various things here. Uh, I don't know. I guess the regular rake or something like Poker Stars would be multiplying by 0.95. I mean the winning pot, and it also has I think a minimum or something like that. I'm not completely sure. Like, okay, this has to be wrong what I just said because I don't recall it. Taking the entire pot if for example a player wins only the small blind or something like that. So okay, I basically forgot about how it works at this point because I can't play the poker for years. Sorry about that. And okay, these are just the handcrafted players he did on his own, and of course the CVR trained agent works the best. It wins very strongly against the random player. Uh, s- mm, oh yeah, the calling machine is actually a lot better. It's not actually that better than the aggressive player. I guess the aggressive player. I guess this agent would only call and raise. This would only call, and this I guess takes the maybe the hand rank into consideration. Hmm, I don't know. So yeah, I'm kind of in a weird position. I don't really feel like yeah, I don't really feel like implementing all of this to be honest. And it would be great if we could just skip to training a neural network with evolutionary algorithms. So maybe instead of even implementing bucketing, we can see that this tight aggressive player has a 0.125. Maybe if we implemented something like this, it would be good as a baseline for training agents with evolutionary algorithms. Okay, let's see what he says here. The bot plays tight if the win rate of the current situation is less than a certain value, and plays aggressive if the win rate of the current situation is more than a certain value. This is essentially an unbalanced player. Their actions perfectly reflect their hand value. So it doesn't have this deterministic player in the table. Maybe I should just ask him about if he would share the source for this tight aggressive player. I'm interested in seeing how he implemented it. Maybe it would be easier to do than any of the other ones. Wait, what's this tight? The bot folds more and raises larger amounts more often. I really like this paper because the other papers that I read before I hit this one were just unintelligible mathematical gibberish. And this guy is similar to me. He's all about the programming. I sent him an email earlier today. I don't know whether he'll reply. Maybe he'll check out some of my own stuff and like it. Continue playing with deep learning and try to implement material and read in CS155. Hmm. Okay. You know, why don't we do? Why don't we do everything according to uh, schedule? We cannot really. I don't know how to make this tight aggressive player even with this description because I don't know what the exact rules are. But we could very easily just implement a calling machine or an aggressive player which just raises or calls. Let's see what he says. The bot folds less and calls larger. Oh, so he does fold. Okay, you know, well, let's implement a calling machine. We'll implement a random player which only calls, and because of that, that means that the poker agent won't be able to just learn to only raise if it wants a good result. If it really wants the best possible result, it will have to learn to actually play good hands. And in fact, we could kind of actually get rid of something like the all-ins from our arsenal. We could allow only pot size bets for the time being, like raise pot, call, and fold. And it will probably learn to never fold against a calling machine, and the calling machine will only ever call. So that way, even if we trade a neural network model using an evolutionary algorithm, we could see some improvement as things go along. Like, if the agent is training properly, it should never take a real loss. If it knows how to read the board and it has a good hand, it will learn to bet aggressively, but otherwise it should just call. And yeah, that should give us something decent in the end. We don't actually need to complicate all of this so much. Like the point of this is not to make a bucketing scheme or anything like that, but simply get it to a point where we can see some actual improvement. And the problem with the random player is because even though it does some folding, it will fold to maybe small bets some of the time, but it will generally act as like a very aggressive player, and it will frequently go all in. Like it's possible to actually even demonstrate this. Let's see. Let's go into no limit hold'em. We'll do a random, and yeah, it's just fucking raising all the time. And you know, if you cannot read the board, that means that whether you call or raise, you have an expected value of 0. But if you fold, then you have a definite negative value. So that's why our own counterfactual regret agents are always playing aggressively, much like the random agent. Yeah, that's what I think. We could also maybe leave the counterfactual regret algorithm aside. Only trade the agent using evolution. That could also be an interesting test, just to see whether we get some kind of decent performance. Yeah, that right now that's the biggest problem in my mind. Actually, getting the agent to maybe learn to read the board in a s- in like a in like a single player environment. That's the biggest issue that I think we have here. So yeah, okay. Let me pause here. I'll think about it just for a bit more, and then we are going to execute the plan. Yeah, yeah. We should maybe leave the counterfactual regret aside for the time being and simply try out making an agent using the cross-entropy method and seeing whether it improves at all. And then we'll be able to compare that against the counter, against the agent that's also using counterfactual regret on top of that. Yeah, that could be interesting. That's what I think. Okay, here's how we're going to do it. What did I do here? Save. And I'm going to make a new branch versus calling machine. I'm going to publish this branch. And now we are going to now I'm going to take a break and pause. And once I've resolved to actually go on a path, be we're going to start programming.